Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about cutting metals. So let's dive right into it. Well, first you have to understand metal are very hard and very solid, aka their density is high and their rigidity is also high, which means they are fundamentally backbone of our in basically 100% of our industry. We humans need this puppy to work, and not to mention one critical aspect of metal is very interesting, that it is very fire resistant. It does not mean it will never burn, and if you put too much oxygen, which a lot of people do when they are using oxyacetylene as in like a cutting gas, where they will start the fire, they start the metal cutting, and then they'll like cut off the gas and just cut through oxygen, because yes, metal does oxidize, it does burn. We use it in rocket fuel. In the case of solid booster, aluminum burns that hot. So yes, it is something that it can catch on fire, something about specifically magnesium alloy. And because of the modern car industry jumping into a lot of magnesium alloy, firefighters are having a hell lot of issue to dealing with that, because you cannot use water, it goes boom if you do that. So it is very fire resistant. Does not mean it's fireproof, but it's very fire resistant. For almost every our day-to-day life, it's can be thought of completely fireproof. That's why we use in car engines where it's going boom 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 hundreds of times per second. So reality is there, it's awesome, it's strong core of our industry. However, it requires a lot of energy to cut. You can cut with a basically hand saw, but good luck with that. I did try to do that with a small hacksaw, and because I'm slowly building my workshop, simply because I have to make a 3D printer extruder, and I thought like, hey, I'm gonna buy aluminum. Cutting this puppy took a lot of energy just by hand. So you can do that. Now this is aluminum, good luck trying to do that with steel, specifically if it's a solid steel and all that jazz. It takes a lot of energy. You can buy snippets that allows you to trim a metal sheet, but again, you have to have strong hand. This is a very high energy intensive process, so very serious business we are talking about here. Now what are your options? Thankfully, because of the importance of metal, there have been thousands of options, thousands of technology that allows you to cut metal in different way, one way or the another. Where you can just have another metal going vujung, cutting it away. You can have a plasma cutting it away, you can have a laser cutting it away, you have grinding disc cutting it away, you can have water cutting it away. So there is more than enough option. You can do a whole PhD and you will still miss something, I can guarantee that. So there's a lot of option. However, I'm going to talk about three important ones here. Now first is angle grinder, basically this puppy. Now this puppy is very small, however ludicrously capable. Basically they run on universal motors and they run at high RPM, and benefit of that, even though this looks small and I can carry it and I'm not a very strong dude, this puppy can cut through thick steel. Like, I got this, bro, I got this, I can cut through it. Like, tangibly they are very powerful, small but powerful. Now there is a bigger version of this which we call chop saw. Now chop saw is generally, this is good for like light workload, but imagine it this way. Let's say you are building a big building and you're using a lot of rebars and concrete, and if you have to cut a lot of rebars to length, utilizing this, you can cut that, but you have to like very slow. Take one, cut it, take two, cut it, take three, cut it. Not efficient. So people generally use chop saws. Chop saws are big, but they are also very capable. And then you have something GG level, which we call band saw. Basically, hacksaws are quite good at cutting something, and they can cut for very small metal. They can cut a very large piece, because in this scenario, your disc keeps getting bigger and bigger. If you want to have, larger cutting area, which you can understand at some point, it will become ludicrous, because again, band saws can go easily to 10 inch to 14 inches, which are huge. This could become huge. So what if you have to cut something very large? So then in those sort of scenario, bandsaw becomes more practical. Bandsaw can cut through like a railway tiles and all that jazz. Like, they are that capable. So bandsaw, while they are huge, they are also very clean. The cut they give, it's like, good, go and enjoy. So that's the three major options. There are many more, but these three are the core of our industry. Now logic, you have to understand, that goes behind this tools selections, choices and all that jazz, because the slower your cut, the better it will be. Let's say you take a metal and you're going vajang to this, problem would be fundamentally how laws of reality works, it will be messy. So you can take an angle grinder and you can cut through almost anything, but here's the, you have to clean the hell up out of after that. Like, let's say you wanted to cut a metal in 90 degree, and you're like, okay, this is a metal stock, I'm going to cut at 45 degree, so I can rotate these two puppy and I get a 90 degree. Awesome design. You did that with angle grinder. Here's the, your metal would be like offset, it will be like this, rather than completely like this, it will be like this or like this, because cut quality is not that high. And then you, once you remove the burring issue, because it leaves a lot of burr, you'll be like, Yeah, it does not look as good. So fundamentally, you want to go slower. Now, how the heck you decide the speed? Now, scientifically speaking, you go with surface meter per minute, or some cases meter per second. So let's say you buy a disc, especially from reputable brands, generally like this is a Bosch standard for metal. This puppy has clearly mentioned 80 meters per second. So basically this edge, the cutting edge, is going through metal. It's like going swing at around 80 meters a second. Now that's fast. Now you have to understand this is a 4-inch disc. What about 6-inch one? Here's the deal. Because it's 6 inches and the circumference is much larger, they have to tone down the RPM. So 4 inches are generally at around 11,000 and 6-inch ones are generally at 9,000 RPM. So do not put 6-inch one here. It will go boom, and that boom event will be very painful if you are lucky. If you are unlucky, you will be dead. So be very mindful of that. So surface travel speed is always try to kept constant. Now 80 meters a second, you will like, dude, that's huge. Yes, it's huge. It's idiotically huge because this puppy is not actually cutting it. Even though it's called cut-off wheel, they don't actually cut. They just grind away. They are very dusty. So this just it's away. It does not cut it away. So it's a very very forceful. It's a very forceful application of energy. Now, if you want to make a small tool that you can carry, something like you can get in a pocket, or like someone like basic dude can like me can hold up. You have to increase the RPM. RPM is your friend if you want to make your tool small. For example, you look at Dremel, the smallest tool that is still capable of working on metal. That puppy can go as high as bonkers as 35,000 RPM. Let that sink in. 35,000 RPM. So big puppy. Then you're talking about angle grinder. Angle grinder is like around 11 to 15,000, and bigger one you go, the lower RPM you get. What about chop saw? Now, when I say chop saw, it does not mean every single chop saw is around 3,500 RPM. Some are a bit more, some are a bit up and down. There is a huge range on that, so be mindful of that. And there would be a very clear mention: do not put this basically blade in RPM that is higher than this. They will always specify that. Like for example, even though this is from Bosch, made for Bosch trade, they will say do not put this puppy at anything that is higher than 14,000. This can easily handle 11,000. It's like, I got this, bro. 12, 13, 14 is like, bro, I'm at max capacity. If you spin it faster than it can literally delaminate. So fundamentally going boom. So that's why RPM is very critical. So you have chop saws that are around 3,500. Now if you want to go like do the same thing that a chop saw does, but you want to do it cleanly, where you don't want to deal with fire hazard, because these are very sparky, and not to mention dusty part. Now dust part is very critical for humans because we have lungs, and given the fact lungs inhale air, and if there is a lot of small iron dust, it will go inside your lung, and that is fundamentally dangerous. Specifically people who are working with what we call stainless steel, there is some alloys mixed into stainless steel which makes it fundamentally toxic to humans. As in, if that dust gets inside you, you will be having a very hard life. Good luck trying to cross 70 years old. So fundamentally you can understand people don't like this topic. Like this is a good starting tool, cheap, efficient, gets the job done, but it's not something that you want to retire with, because you may not live long enough. So we go to cold saw. Now cold saw rotates at much lower RPM, so around 1500 RPM, so to say. Now you might be like, hey, why don't I take a speed regulator and tone down these basically universal motors on these things and just enjoy. Here's the deal: if you reduce the RPM of an induction basically universal motor, the torque also goes down. Torque is like a factor, it's like an ampere. So your total oomph on a motor is fixed. Basically how much oomph you can get out of it is fixed one way or the another. So it's almost like a watt. So your transformer can increase the voltage, but it will by default decrease the ampere. So same thing happens here. So if you have a motor that is not designed for that RPM, outcome will be low torque. So you cannot just tone down this. So generally people use induction motor. Benefit: induction motors don't have brush, they have very long life. Fundamentally you can keep replenishing it for hundreds of years, and people have done that. Like 100-year-old induction motor are still in service. So people go with cold saw. Now cold saw is like good, it's a new kind of thing. But how do big people like where you have a lot of money and you want to fabricate a lot of things, like you want to build a container ship, you want to build something solid, something rigid, where you have to work with tubular steel, and you'll be like, dude, this has to be clean, I ain't got time for this. You utilize pro cold saw. Now these saws, they rotate at 100 RPM, and be mindful, 100 is more. They generally have like high speed of 56 RPM. So like, what the hell? Yeah, they generally have 3 horsepower motor, and that is like geared box shifted into the there is no belt, there is no small pulley. They have like a freaking huge gearbox turning the blade. Benefit of that, this puppy gives so clean output that if you take a basically square bar and you're just like cut it, you can chuck that into a mill and it will be precise. Like you can do surface cut on that, it will like almost nothing. It's like that precise. So if you want to make something precisely, like for many people who use tubular steel, this kind of tool is priceless to them, because they can take a tubular steel, cut it at 45-degree, rotate the one section, and complete it to the welding 90-degree. They don't even have to check it again, they don't even have to bring an angle square. It's like that's good. So pro cold saw is there. So that's the logic. The higher the RPM, the less life, the less safe it is, but smaller it becomes. So if you want to survive long, try to go as low RPM as possible. Now at 1500, you start to reduce the spark risk from flamethrower to like so one or two sparks, one here and there. And then when you go to pro level things, and they have flat out flood cooling, so they cannot even have sparks even if they want to. So this is the logic behind the tools that we use for cutting, especially things that rotate. Now what about fluid? Now fluid is kind of more thought of when you're thinking about milling or drilling, but here it's also important. However, because grinding disc, they are relying on kind of high temperature, they are abrasive. Applying a lubrication there is not a good idea. So fundamentally we don't use that when you are using angle grinders, things of that nature. But if you're using something like a cold saw or a band saw, this becomes priceless at that point. Specifically if you're dealing with big stuff, they're like, dude, get a cooling. Now the reason for that is band saw and cold saw are running at very low RPM, so they are spending more time grinding against your material. Like fundamentally that 1 square inch you can take on a blade, it's not interacting with air that much. Like at higher RPM, air is interacting more with you, but at low RPM that's not happening. So cooling allows you to have more accurate, because your metal blade will not go wobbly wobbly wobbly. It happens. And because we think of metal as in like black and white kind of scenario. It's like, oh, it's a solid in room temperature, liquid at 3000 degrees Celsius. But here's there is a transition period. So if it heats up to, let's say, 300 degrees Celsius, it starts to become wobbly. So you don't want that. That's why we want to keep it cool. And another aspect is heat dulls the blade. So it does not matter whether you have cold saw, hacksaw, or chop saw, whatever have you, the blades always get dull with basically temperature. Now earlier I did not used to understand that, like, hey, it's metal, it's supposed to be fished at like very high temperature, like 1500 degrees Celsius. Here's the deal, you can start to work metal, as in like shape metal into whatever form you want to do, as early as 300 degrees Celsius, which they can easily achieve at the tips. So if your tip is getting hot and it's going against a metal at full force, like let's say how much horsepower you put, that means it's going badang to a metal, it's gonna bend. And that happens. And you might be like, why can't we make stronger metal? We did. Problem is it becomes brittle. So you, instead of going badang, it goes fa-ching, cracks like a glass. Your blade will fatang. That's why cooling is used. So that's why if you go with a professional cold saw, they're like, just shut up and do cooling. That's it. Like they will not even talk about it. Like it's a high speed steel blade, just use cooling because it's necessary in that sort of scenario. So fundamentally cooling is not required for low level stuff, but if you want to do big stuff and you want to make sure your saw lasts longer, do invest in cooling. That will help you a lot. Now this is one thing you have to understand. Many other things like drills and all that, we kind of improve. Like you buy a drill and then you build a drill stand, so you have a more oomph out of it. Same can be done with cutting. So let's say, for example, many of you will have angle grinders, and you can start with this. The first thing you should make is trying to make some sort. It does not matter you make out of wood, metal, galvanized pipe, or PVC pipe. Does not matter. Make some sort of basically slide that will allow you to do multiple passes on one metal cut. So basically, you do not want to plunge this puppy. You really don't want to plunge this puppy. It can do that, it will try to do that, and the engineers who designed this, they designed it at worst case scenarios, like where you are doing that all the time, but it's not good. And not to mention your tool, this blade you have to buy, you're like, hey, they're cheap, but here's the deal, if you're going through 10-20 of them per month, it starts to add up. And not to mention, that's not good. That simply means you are wasting energy. So using a slide, you will get the advantage. Just like lightly score a sheet metal, then you score a little bit deeper, like multiple passes. It becomes easier to do if you have a basically slider. And I am trying to build my own slider. The parts are right here, like literally here, parts are here. I have not completed it, that's why I'm not showing it in camera, but I'm hoping by next week I should be able to finish it. So you can start with that, and that will allow you to do more things with your existing tool. Then cold chop saw, because right now cold saws are not something that is like available everywhere. Even in India, like there are very few places where you can buy that flat out. So people are just like, okay, I'm done, I'm gonna build my own. And thankfully, because the induction motors are so common, you can just buy it, and the RPM matches almost accurately. So like if you are living in a country that is like around 50 hertz, You literally have the same RPM. You don't even have to do a step down, especially if you are living in a place which has 60 hertz, then you want to have some slowdown with the pulley. But other than that, you don't have to do too much. So a lot of people are building that, and one YouTuber built god tier level. Dude's name is Made in Poland, amazing name, and he built something quite amazing. Like if you have this, it's like, bro, I got this. You're gonna cut through box sheet metal like you don't even care. It's like, oh, metal, go, I ain't got time for this. So it's amazing things. So it's a very good addition to tools. Basically, you can have a tool and you can upgrade the tools using the tool itself, so you can go all Thanos on it. So fundamentally, DIY is a very good option nowadays, and given the fact that the amount of tutorials available on YouTube, whoa. So this was my presentation on cutting metals. I hope you liked it, learn from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me your disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.